So now guys, this is the video for the exam 2 of the second term and for the grade 11. There were some extra examples about the circles which I prepared for extra time if we can get, but we didn't get such extra time. But I have prepared it in any way. Some people, some students, they want to know the answers of those questions. I decided to make a video of it. So let's start with the first one. I was able to solve these two questions in every class from the extra part. So now here we have one more question. We have solved something similar with this one. Okay guys, in this example we need to get the alpha. To get the alpha we need two places. We need the arc over there, the blue one, and the purple one. So purple minus the blue one, purple minus blue over alpha over 2 will be equal to alpha. So now, how can we use these things, these given things to us? Let's check that. First thing, if I name these two arcs like A and B, A plus B over 2 is going to be equal to the interior angle 80. So here I can get that A plus B is 80 degree, 2 times 80 will be 160. So the purple arc, which is A plus B plus 66. So let's write it over there. So 160 plus 66 is going to be 226 degree. So now after we find 226 degree, since we have whole circle over there, the blue part is going to be 360 minus 226, which is number 4. 5 minus 2 will be 3, and 134. 134 will be there. So the alpha equals the larger arc 226 minus smaller one 134 over 2. 6 minus 4. So 12 minus 3 will be 9. 92 over 2. Is 45 and 46 degree it will be. So now the second example over there, find the value of alpha, which is 100 given over there. In this example we are going to use the naming method which I have mentioned in the class. Opposite of alpha, the arc from B to the C is going to be to right of it, since alpha is an inscribed angle and the corner of it is on the circle. So then how can I show this smaller part? How can I express it, explain it, or with the naming alpha? Since whole circle is equal to 360, so 360 minus 100, 260, minus 2 alpha will be this place. 260 minus 2 alpha. So then the 60 degree, the exterior angle equals, so it makes two arcs over there. The larger one, which is 2 alpha, minus the smaller one, which we just have told that 260 minus 2 alpha over 2. If you do the cross product, there will be 122 alpha minus times 260 minus times minus 2 alpha is going to be plus 2 alpha. So then 4 alpha equals, if you put minus 260 in here, it's going to be plus 260 and plus 120, 0, 8, and 380. So alpha equals 380 over 4. So let's click for once again, which is 4 times 8, 32, 4 times 9, 36. So 36, that remains 20, 4 times 5, 95 it should be. So now let's continue. So here we have the example which we have solved exactly same one in the class. Let's use the formula for this one. If you have two tangents, the angle outside and arms of it, if they are both tangents, the arc and the angle. Sum of these two things should be 180 degree, or how can we write it mathematically? 60 plus arc, the arc QR should be equal to 180. So the arc QR should be equal to 120 degree. If this place is 120, the other one should be 360 minus 120, which is 240 degree. So since x is an inscribed angle, the corner of it on the circle, so if this one is x, the opposite arc should be equal to twice of the x, so x must be 120 degree. So let's move on here. It's a very simple example. I think we have solved exactly similar question. So to find the x, we need to know the two arcs it makes. We know the larger one. To find the smaller one, twice of 15, 30. So x is equal to large arc minus smaller arc over 2, 70, 35. Let's continue. So in the figure, DE is an arc with the center, with arc of the circle with the center O, and OABC is a square over there, and we want to find the alpha, the angle alpha from here. So now guys, how can we do this one? Okay, so let's start. First thing, if I draw the diagonal here, since it's a square, there will be 45 degree over there and 90 degree. And secondly, the direct line from center to the chord, which is if I continue to draw the circle and extend this line over there, so from B to this place, there will be a chord. The direct line drawn, which is from center to the chord, it will bisect the chord. So if this is double line, this one will be double line as well. And secondly, if you draw the radius over there, since it bisects the sides, it's going to bisect the angle as well. Also, you can say that here we have isosceles triangle, and it should be, since there is 90 degree, 45 and 45. Then later, since this is alpha and I'm working with circles, I need to make it like with circles. So opposite of alpha, the inscribed arc, this arc should be double of it, which is twice of alpha. Twice of alpha. So the angle from center, or the central angle should be same with the arc. So 45 equals to alpha, then alpha equals half of 45, 22.5 degree. So now let's continue with this one. Okay, we want to find the x. To find x, we need two arcs from A to the C, the smaller one, and the bigger one from A to the D, the bigger one. So look at that. Here we have the 60 degree, which is the angle between chord and tangent line. So it is something like inscribed angle. The opposite arc, half of 260, which makes 120 degree. So x equals 120 minus 40 over 2, which is 80 over 240 also. So now let's continue. Is there any more pages? Yes, there are some more. Just find the alpha, which we know that O is the center from here. Also, here we can use the rule. Some other things as well we can use. Hi, let's start. So now guys, if I draw the radius in this place as well, so the radius which you draw from center to the tangent line, there will be 90 degree over there. Also in this place there will be 90 degree. Since we have a quadrilateral in here, 90 degree plus 90 degree plus 50 degree plus, let's say alpha, alpha is already used. Let's say x, which is 90 plus 90 plus 50 plus x from quadrilateral should be equal to 360 degree. Here we have 180 There will be 180 in this place. So 180, if you put 50 in here, it's going to be a minus 50. So 180 minus 50, that remains 130 for the x. X must be equal to 130. So since both of them are radius and radius, isosceles triangle will be there, and this one should be alpha also, which means x plus alpha from the triangle should be equal to 180 degree. Since this is 130, 2 alpha should be 130 will be minus 130 in the right side, and there will be 50 degree. Alpha equals half of 50, 25 degrees. Let's continue the next example. We have solved a similar example in the class with this one, if I remember. For the class B, D, and E, for those classes, it was the first example. Look at that. I also showed you several ways to show it. Let's do the one which I like very much. Opposite of alpha will be 2 alpha. So this 2 alpha is related with 35. It can be related with 60. Let's use it as 35. So the other arc which is related with 35 is the larger one. So I need to get the larger one with the naming alpha. So here we have a triangle. Let's draw it with green. So 60 is exterior angle for this triangle. So sum of two interior angles should be same with 60, which means this angle can be shown as 60 minus alpha from here. And the purple arc is opposite of this inscribed angle, so which is twice of this one, 120 minus 2 alpha. Then 35 equals large arc 120 minus 2 alpha minus smaller arc 2 alpha, the purple one, this one, not the purple, is the larger one, 2 alpha over 2. Then if you do the cross product, 2 times 35, 120 minus 4 alpha will be there. I don't like minus before unknown. I want to make it positive 4 alpha equals 120, and 70 will be moved in here as minus 70. So then it's going to be 50. Then alpha equals 50 over 4, which is 25 over 2 can be shown. It is also can be written as 12.5 degrees. Let's put the degree sign at the end for the result. Yes, for the result. So here we have the last question, which is I don't like to ask verbal things in geometry, but what if it is there? It won't be that, but let's put it to the video for my YouTube account, YouTube place. Let's do that. AB is the diameter of the semicircle centered at O. So we need a semicircle. Let's put one hole. So let's make a diameter for this one. Let's say this is the diameter, and the points A and B, and the center O, let's say somewhere here. Then C and D are 2 points on the semicircle, and P is a point outside of the circle. P is a point outside of the circle. C and D will be somewhere on the circle, somewhere on the semicircle, okay? Such that PBA and PCD, PBA and PCD are collinear, means they are on the same line. P, B, and A should be on the same line. That's why I need to put the point P somewhere here, which can be on the same line. Let's extend the diameter over there. P, B, and A. Let's clean the other one over from there. So then P, C, D. So C and D are 2 points on the semicircle. So if I draw a line cutting this one, let's say C and D are collinear. They are on the same line. Okay. This is like the angle from outside. Let's check that. Are collinear. Given that the measurement of DAP A and P. If I add this one, I'm gonna get that angle D, A and P. The angle in here should be 60 degree, and other one, the angle P, is the one in here. There is nothing else. 22 degree, and we want to find the angle DC and O. So D, C and O. We want to find this angle. Let's name it as X. So the shape should be something like this. So it can be in a different ratio. Let's go with this one. So firstly, look at that. So now, let's see, how can we start? Like in the class, let's start with the thing which we can do directly, which is opposite of 60. This part is gonna be 120. But let's check that will it help us. So with 22, we will need this one and the other arc. So there is a tricky point in this one, I think. Let's try to find that tricky point. 60 degree should be the tricky point. So we have done an example like this before, if you remember that. If I add this line, since these two, from O to A, from O to D, since these two are radius, there is going to be something like isosceles triangle. So base angles should be same. This one should be 60 as well. This one should be 60 also. From here, we can say that the central angle 60, opposite of it, opposite arc of the central angle should be same with 60. So look at that. With this 60 and 22, I can combine them. So 60 minus this place, let's name it with another letter y. 60 minus y over 2 should be 22. From here, I can get that 2 times 22 will be 44. I don't like minus y. I want to make it plus y, and minus 44 will be there. It's going to be 20 and 16. So the arc y will be 16 degree. The arc y will be 16 degree. So that if the arc y is 16 degree, the angle, the central angle opposite to this arc will be 16 degree also. So then to find x, now here we have the tricky point. To find the x, we will use this triangle, C, O, and P. So inside the COP, the two interior angles equal sum of one exterior angle. So x is equal to exterior angle, which is 16 plus 22, which makes 8, and C, 38 degree. Thank you for listening.